Kilauea just started episode 47 of its ongoing summit eruption. The footage is spectacular. This is not a disaster. The lava is confined inside Halemaʻumaʻu crater. The crater is inside Hawai'i Volcanoes National Park. No homes are being threatened, no communities are being evacuated. But a lava plume reaching 20,000 feet, Tephra falling on Highway 11, and a magma chamber that the United States Geological Survey can read like a clock. All of that is happening right now. On Thursday, May 14, 2026, at 3:27 p.m. Hawaii Standard Time, the Hawaiian Volcano Observatory recorded the onset of episode 47 lava fountaining at the summit of Kilauea. Activity is focused at the north vent. Fountains reached approximately 650 feet above ground level. The eruption plume reached 20,000 feet above mean sea level, as confirmed by National Weather Service radar. Volcano Alert Level, watch. Aviation Color Code orange. Kilauea has been continuously erupting from its summit since December 23, 2024, more than 500 days ago. Each previous episode ended with a measurable contraction of the summit ground. Each contraction was followed by a measurable expansion. Each cycle has been read, recorded, and now published by USGS scientists who know what to look for. But here is the detail that tells the real story. Most viewers register Kilauea as either a tourist attraction or as the 2018 Lower East Rift Zone disaster that destroyed 700 homes in Leilani Estates. Neither framing matches what is happening at the summit today. What is almost nowhere reported is that USGS scientists predicted episode 47 days in advance. The first forecast window was issued on May 9. By the morning of May 14, it had been narrowed to a single line, today at any time. Episode 47 began at 3:27 p.m. that same day. The volcano started at exactly the time the tiltmeters predicted. The question is what it means when a volcano starts behaving so predictably that we can publish its schedule before each pulse. This is what USGS observed on Thursday. Episode 47 did not start at 3:27 p.m. It started at 2:57 a.m. That was the time the first precursory lava overflow began from the south vent at Halemaʻumaʻu. Over the next 4 hours, 6 discrete overflows occurred, each lasting 20 to 30 minutes. Glow, flames, and spatter bursts were observed at the north vent. At 7 a.m., HST, HVO, narrowed the forecast window further. Then the W8, 8 hours of precursors, increasingly vigorous spattering at the north vent. The Uekahuna tiltmeter station registering the final increments of inflation before the threshold. At 3:27 p.m., the north vent ignited into a sustained lava fountain. HVO issued volcanic activity notice. H. 227:14 minutes later. By 5:18 p.m., Plume altitudes were confirmed up to 20,000 feet via NWS radar. The pattern of the episode itself is also a story. The south vent is producing cyclical overflows and periodic spattering, but no fountains. This is the third consecutive episode in which the south vent has not fountained. The system is funneling its output through a single conduit. Surface winds from the northeast carried tephra and gas to the southwest, including parts of the Cow District. All eruptive activity remained inside the closed area of the national park. From 2:57 a.m. to 3:27 p.m. 12 hours and 30 minutes, from the first overflow to the first fountain. The VOLC. This is what almost nobody outside USGS understands about Kilauea. Every lava fountaining episode of this eruption follows the same internal pattern. Before each pulse, the volcano inflates. During each pulse, it deflates. Between each pulse, it inflates again. The magma chamber breathes in, it breathes out. The instruments measure the breath. Beneath the floor of the summit caldera, approximately 1 to 2 kilometers down, there is a shallow magma reservoir. When the volcano is paused, magma rises into this reservoir from deeper in the system. The reservoir pressurizes. The ground above tilts outward by tiny but measurable angles. The instrument that measures these angles is a tiltmeter. The unit is the microradian, 1/1,000,000th of a radian, the angle of a 1 kilometer baseline tilting by 1 millimeter at one end. Sub-millimeter precision. During episode 46, the Wekahuna instrument recorded 14.0 microradians of df tilt as the reservoir emptied to feed the fountains. Between May 5 and May 14, it recorded 15.4 microradians of inflationary tilt, slightly more than the previous deflation. The reservoir had refilled to a pressure level slightly higher than where it sat before episode 46. That ratio is the forecast key. When inflation reaches the threshold set by the previous pre-eruption tilt level, the system is full enough to erupt again. The forecast window narrows as the threshold approaches. On May 14, the threshold was crossed. USGS knew episode 47 was coming. The volcano had been telling them for days. This is the first volcano in the world that scientists can read like a calendar. The instruments are not predicting the volcano is talking to the instruments. This is why it still matters even though nobody's home is being threatened. The lava is contained inside the crater. The hazards are downwind and atmospheric. Tephra is the umbrella term for glassy volcanic fragments produced by the fountains, ash, pumice, scoria, Paley's hair, and reticulite. Larger particles fall near the vents, lighter fragments are carried downwind. During episode 46, Tephra, as large as 6 inches, fell across Highway 11 between mile markers 30 and 34. Volcanic glass, the size of a fist, more than 6 kilometers from the vent. Paley's hair is its own category. Each fragment is a thin strand of wind-blown volcanic glass. Contact causes skin, eye, and respiratory irritation. Then there is the sulfur dioxide. Sulfur dioxide reacts in the atmosphere with sunlight and water vapor to produce volcanic air pollution that drifts across the southwestern districts of Hawai'i Island on prevailing winds. Sulfur dioxide emission rate during pauses, 1,000 to 5,000 tons per day. During active fountaining, substantially higher. A 20,000-foot plume reaches commercial aviation flight levels. That is what Aviation Color Code ORANGE represents. The fire is in the crater. The hazard is in the air. The communities downwind are not in the path of the lava, they are in the path of the plume. To understand why Kilauea is doing this, look deeper than the reservoir. Kilauea is a hotspot volcano. The Hawaiian island chain sits over a deep mantle plume, a column of hot, partially molten rock rising from far below the lithosphere. The plume has been delivering magma to the surface for tens of millions of years. And here is the part that is genuinely unusual. Recent episodes have been progressively smaller. Each one drains less than the one before. Each pause is shorter. The intervals between episodes 45, 46, and 47 have compressed. The fountains are still reaching impressive heights, but the volume of magma drained per episode has trended down. The volcano is not getting more violent. It is getting more regular. A higher frequency with a lower amplitude rhythm. And it is still going. The tiltmeters at Wekahuna are already measuring the deflation that will set the timer for episode 48. The question is not whether Kilauea is still erupting. It is. The plume is in the sky. The pattern is in the data. The question is not whether this is a community disaster. It is not. Every fountaining episode of this eruption since December 23, 2024 has been contained inside Halemaʻumaʻu. The 2018 Lower East Rift Zone disaster that destroyed Leilani Estates was a different eruption mode at a different location on the volcano. The 2026 summit eruption is a different story. The question is what it means when a volcano starts behaving like a clock. 47 episodes in 18 months, each one slightly smaller than the last. Each pause slightly shorter than the one before. Each pulse announced by tiltmeters that have learned to read the magma chamber as well as the magma chamber reads itself. The lava is still in Halemaʻumaʻu, the Tephra is still on Highway 11, the Pele's hair is still drifting toward Ka'u, and the tiltmeters are already counting toward episode 48. The next pulse has not been scheduled, but the volcano is already telling us when it will be. If this story is worth telling, subscribe. We cover more of these every week.